Uh, Deadlock detection in distributed system. Hello guys, my name is Rella Dinesh from CSITA section. My tech talk concept in operating system is deadlock detection in distributed system. Now we will see the introduction. Introduction to deadlock detection in distributed system. What is deadlock? We will see now. Deadlocks occurs when two or more processes are unable to processed because each is waiting for other to release a resources. Other to release a resources. Okay. Hmm. In distributed system, deadlocks can occur when process occurs different nodes and involved in resource allocation. Deadlock detection is essential to prevent system-wide failure and ensure the overall reliability of distributed system. Name is in what is distributed system? Name itself is indicating it is a distributed system. One resources can be resources are distributed into many systems. This is a one type of a software operating system. In mainly in this distributed system, if one resources is retrieved by both by many distributed systems, then deadlock will occur. What is deadlock? Normally, deadlock is a process where unable to process it because each is waiting. One of them is waiting for another to release the resources. Okay. Okay, this is the deadlock detection. Without deadlock detection, the widely system failures will occur in distributed system. By using deadlock detection, we will prevent the system-wide failures, and we will increase the reliability also. Here we can see the deadlock detection in single instance and multiple instance. In single instance, we have wait for graph and multiple safety algorithm. Now we will see about the types of deadlocks in distributed system. Resource deadlocks. First one, resource deadlock occurs when processes across different nodes and waiting for resources held by other processes. Process resource deadlock. A deadlock is a one type of a deadlock where it occurs when nodes are waiting for resources held by other processes. Okay. Communication deadlock. It arises when processes are waiting to message or acknowledge it from the other process. First one is waiting for resources. Second one is waited for acknowledgement, or we can call as a message. And distributed deadlock. It involves multiple nodes and resources that can lead system-wide deadlock situation. Now we'll see the challenges in the deadlock detection in distributed system. Lack of global state, communication overhead, scalability. Lack of global state, distributed system, lack of global view, making it challenging to detect deadlocks. It does not have global view. That's why it is challenging to detect the deadlocks. Okay. Second was communication overhead. Deadlock detection algorithm requires a communication among the nodes, introduction, and overhead. Third one is scalability. As the number of nodes and resources in distributed system grows, the complexity of deadlock detection increases. Where we can say as deadlock detection is directly proportional scalability. As the scalability means increasing the nodes. Increasing the nodes will increases the complexity of deadlock detection. Detection will become complex while increasing the nodes. And for approaches to the deadlock detection. Centralized deadlock detection. A centralized deadlock detection coordinates the monitor resources allocated and detects deadlock across the system. Distributed deadlock detection nodes exchanges information to collectively detect deadline without a central coordinator. Hierarchical deadlock detection. These are three types of deadlock detections. It is a combination of centralized and distributed approaches by grouping the nodes into a cluster and deadlock detection. First, centralized. In this detection, the resource allocations are coordinated to the monitor, and say distributed deadlock detection. Nodes exchange information collectively. Nodes within the nodes, information will exchanges in hierarchy manner. It combines it is a combination of centralized and distributed. It makes cluster of both. Now we'll see the centralized deadlock detection algorithm. Maintaining a waiting for a graph to track resources dependency between process. Periodically analyzes the graph for a cycle, indicating the potential deadlocks. If a cycle is detected, the centralized coordinator triggered appropriate action to resolve the deadlock. When this deadlock is occur, when there is a graph or cycle indicates the potential deadlock, then this cycle of deadlock will trigger the centralized coordinator, then this deadlock will be resolved. Now we'll see the distributed deadlock detection algorithm. Nodes exchange resources, allocations, and dependency information with their neighbors. Normally, the nodes will exchange the information between them. Each node analyzes the received information to detect the local deadlocks. Global deadlock detection is achieved to aggregate the local deadlock information from all the nodes. These are the nodes which are systems S1, S2, S1, where the P1 process P1 is connected to process P8. Here deadlock is and model. Uh, there is a cycle, but not, and no deadlock is in the R model. Normally, deadlock is follows the AND model, and no deadlock follows the R model. Uh, Nodes hierarchical deadlock detection algorithm. This picture is about hierarchical deadlock algorithm, where it is a combination of distributed and uh, okay. Nodes are organized in the cluster with a cluster coordinator responsible for deadlock detection within the cluster. Cluster coordinator exchange deadlock information to detect the system-wide deadlocks. Provides the balance between centralized and distributed approaches, efficient waiting, and resolve the potential deadlock. By using this deadlock, the resources preemption will be resolved and timeout mechanism also resolved, process termination also resolved. Challenging in deadlock resolution, data consistency, fairness, and minimizing. Data consistency, resolving the data deadlock may impact data consistency. Data can process continuously, consistently. And the fairness, balancing the need, fairness means it will balances the deadlock efficiently, minimize the disruption. Deadlock resource strategy should aim to minimize the disruptions because to decrease the burden in operating system. Okay. Now we will see about the deadlock detection tools and frameworks. Now some frameworks we will see. Apache Zookeeper provides the distributed coordination service for a deadlock detection in distributed system. Console offer a key value store and service discovered a capability of detecting the resolving deadlocks. Netflix Hello, a detecting deadlocks in distributing data process system. Now we'll see about the case study and Google Cloud Spanning. These are the all deadlocks where Zookeeper service, where in the Zookeeper service, where it coordinates services the deadlocks. It provides distributed coordinate. Where console, it stores the deadlocks in key value pairs. Netflix Hello, a data synchronizes. In this system, in this detection, the deadlocks are in synchronized way. Detect the deadlocks distributed process system. Now we'll see the case study. Amazon Dynamo database employee a highly available and scalable distributed database system. DynamoDB uses the partitioned and replication to handle the high output and ensure the fault tolerance. Deadlock detection mechanism in DynamoDB focus on efficiency resources utilizes and conflict resource maintaining the system performance. Amazon DynamoDB used this deadlock system to enhance the utilization and and conflict resources and maintaining the system performance efficiently. Now we will see about the best practice of deadlock detection in distributed system. Uh, Implementation, monitoring, and logging mechanism to track the resources allocated and detect the deadlock pattern. Implementing, okay, utilizing the distributed consensus algorithm to coordinate deadlock resolved across us. Regularly review, optimize the deadlock detection algorithm to adopt the changing system requirement and scale. These code studio is deadlock detection. Deadlock detection is done by the patterns, where morely used future trend of deadlock detection is machine learning, blockchaining, and quantum computing. Machine learning, AML. AI and machine learning algorithm have predicted deadlock detection and resolution. Uh, Blockchaining technologies exploring the blockchaining based on approaches, the detection in distributed system, quantum computing investigating that potential of quantum optimize the deadlock detection algorithm is highly complex distributed environment. Now we'll see the conclusion. Deadlock detection is a crucial aspect of ensuring the reliability and performance of a distributed system. Various approaches, algorithm tools exist to detect the resolved deadline in distributed environment. Continuous resources and innovations are essential to address involving the challenges and complexity. Deadlock detection is modern distributed system. These are the references. This is acknowledgement. We would like to thank the researchers and practitioners in the field's distributed system of their valuable contribution. Thank you. Normally, this deadlock distributions deadlock system is used in. Normally, this detection is used in distributed system to detect the one resources accessed by how many processes are waiting for that resources. By using these has the track of the waiting processes which have to be processed. In the absence of deadlock detection, we cannot have the track of deadlocks. All the process will be in the process waiting state only. Thank you, and I have a nice day.